what is Inventor LT? Maybe actually easier just to kind of show you what it is. For the most part, it's an Autodesk product that just does parts and drawing. So here we are at the sketch mode. You can see I've got some sketch constraints in here, and I can add some more constraints. Just add a tangent constraint between that line and that circle. And now if I drag him around, you can see I get some dynamic motion. I can add another constraint just by dragging. And now when I drag this guy around, again I get some dynamic motion. So we have parametric dimensions and drag base constraint, which makes the sketcher very powerful. Now, does this look like a pretty complicated part? Kinda does, but to tell you the truth, it's just made with two simple sketches. One from the side view and one from the top view. Just to show you, I'm going to expand all these features, and you'll notice that it either says sketch number 1 or sketch number 2 underneath it. You do them in the right order, you can do it with two simple sketches. And back to the parametrics of it all, we can make this geodesic dome, and we can make it driven. If I change this dimension, add on 4 more feet, hit the update button, you can see the geometry plays along and creates our geometry. Getting into a little bit more complicated shape, we can start using other features than the extrude, such as sweeps. And if you happen to grab your competitor's JPEG off of his website, all you have to do is trace around it in a sketch and just extrude it. Now this one we've gone ahead and extruded it, and we've added the option to do different solid bodies. So drag it all the way to the end. This gives us a little bit more advantage, so we can work on each of these as individuals and hide the others and just work on this guy all by himself. If we want to show a more stylized part, all you have to do is right click on the faces, go to the properties, hit the drop down, and I'll pick machined 01. You can see it just changes that face color to where it looks as if it's machined. Next, back to some simple parametrics. I've got a 2x4 rectangle, and it's just extruded 12 inches. Fairly simple, but I can go from the Manage tab to create an eye part. Go and add 2 records in the database. Maybe I've got this next part number that's 24 inches, and another one that's 36, and maybe even a little bit bigger. So we change these dimensional changes, hit OK. We now have a table in the browser. We can double click the parts and watch them update. If we have a DWG drawing that's associated with that, all we have to do is go to the Annotate tab, create a table, select the view, go to the column chooser, and we'll just add the different parameters that we want in our table. That way it fully dimensions out dimension A1, B1, and length. If I make an update in the part, it's going to automatically update this drawing. It's fully associative. Now on to a more complicated eye part, or a table driven part. This one is actually driven by an Excel spreadsheet. You can kind of see at the very beginning we do have our part numbers and some just dimensional changes, but then we get into calculations and suppressing or computing different features depending on those calculations. So on this first part number, you can see it has all the different features. If we double click on the second one, you can see that the majority of the features are actually suppressed or not active. This gives us a very powerful way in which we can update and change families of parts without having to spend a lot of man hours doing it. Another way to optimize your models, just by going to the Manage tab, going into Parameters, and adding your own custom equations. So here, if I want to change the length of this ladder by 4 feet, All we got to do is say done, hit the update button, and it automatically adds the rungs as needed. And in the same manner, we have this spiral staircase. It's driven by a couple sketches. So we go in and edit sketch number 1. Go ahead and just add 2 feet onto the length of that step. Finish the sketch. And our spiral staircase is up to date. If it's up to date, we can go to the drawing. We can take this drawing view, right click it, and actually insert that into model space. This is a DWG file, so right now in Inventor we're playing in paper space, but now what I've done is I've actually inserted a AutoCAD block into the model space view. If we go into the open dialog, you can see we have a wide array of translators including CATIA, ProEngineer, SolidWorks, and Unigraphics files. And who better to work with your AutoCAD DWG files than Autodesk products. Here I am in the sketch mode, and you'll also see that I have a little AutoCAD icon that I can insert any 2D geometry right inside the sketch. That's where this information came from. With the data available, then all I have to do is extrude it bit by bit. And if I want to go ahead and add a little cut in the part, just go grab the extrude command, tell it it's a cut, and I'll tell it to go all the way through the part. Simple as that. Inventor LT fully supports multi-bodies. So I could build this as if it were separate components, and then somebody with full-blown Inventor can hit the export or make parts feature, and that will export it as an assembly and each of the individual solid bodies as individual. Soon you got to get back to work and you got to start modeling up compressor caps or 747 fuselages. Let's go ahead and check this just a little bit. We'll make sure that this door is the right size. So go to the distance function. We'll go from that point to there, and it's 75 inches. I think I can fit through there. And going from aircraft to marine, here's a impeller for a ocean going vessel, and it has some pretty complicated curves on it. This guy is ready for production. So we'll come from there and we'll take a look at modeling up some of the detail of a shoe. That's pretty cool. Now a lot of that may seem hard, but here all I have is 2 lines and a circle. All I got to do is go into the coil command. Inventor LT makes it very simple. I just have to select an axis. I can link my height to a dimension and just tell it maybe I want 5 revolves around there. Hit the OK button, and I've made a pretty complicated little helical coil with only about 3 clicks. If you want to get fancy, we can make square helixes. And if you want to get ultra fancy, we can even do a helix about a helix. That one took a while to think about. Next, we'll move away from the modeling environment and go right into Inventor Studio. I'll go ahead and hit the render image button. Go ahead and click on the render button, and we'll watch it render real time. So it's taking what's in the background. Very powerful rendering engine. Goes in there, applies all the material textures to it. If there's any shadows or reflections, any anti-aliasing, automatically calculates for that. When we're done, we can hit the save button, save it as a bitmap or JPEG or whatever you need. So going back to my list, I could keep on listing features and benefits. Like one big one, you also get AutoCAD LT. So you remember the spiral stair DWG that we had earlier? Notice we have a model space, we have a top view, and any of the views that were created here, we can actually insert them as regular AutoCAD blocks. So you can see the different views. So we can use some very creative workflows going from 2D to 3D to 2D. So to finish up my list, I think it's going to be easier just to say, what can Inventor LT not do? Cannot do assemblies, cannot do sheet metal parts, and there's no vault support. Thanks for watching.